In this lesson, we're going to look at some applications involving these right triangles. So in order to be able to do these applications, we have to know two vocab words, angle of depression versus the angle of elevation. So basically, if we have an angle of depression, we measure from this horizontal line up here, and we measure the angle down to be able to see like this person here. So the angle of depression from up top here down to this person is going from this horizontal line and that angle to be able to reach that person. The angle of elevation from this person to the hot air balloon, we measure from the horizontal line down below all the way up until we see that hot air balloon. If you notice, the angle of elevation is equal to the angle of depression. So see how we have 38 and 38? And that's because these horizontal lines are parallel to each other, and these angles here are actually alternate interior angles. So whenever you have parallel lines and you have alternate interior angles, they're congruent, which is why this has to be congruent. So when we're looking at these, elevation, you're measuring upward. So you always measure from the horizon or the horizontal line. So if I'm starting here and I'm going from this island up to the plane, the angle of elevation is down from here, this horizontal line, up to that plane. So it's always got to be measuring from a horizontal line. It's measuring from the horizon. So if you look at the angle of depression, it's a little bit more easily confused, I would say. Because if you're looking at this first example does represent the angle of depression because you're measuring from the horizontal line down to this island, so that angle there. Where if you look at example 2, this is incorrect. This angle 1 is not the angle of depression because it's not measured from a horizontal line. In order for it to actually work, I would have to draw my horizontal line, and it's this angle here from the horizontal line down to the car would be my um, angle of depression. So if you look, this is the correct version over here. So this one we don't really want to look at, but that's the most common mistake I've seen with these. So always make sure that you're measuring elevation and depression from the horizontal line. So let's look at some examples here. So this first example, it's talking about a ladder that's leaning up against a wall or up against a building. So this is my ladder here. It's leaning up against this building. So this will be the building. So here's the ladder. And it says that it makes an angle of 58 degrees with level ground. So here's the ground. And the ladder is making an angle with the ground of 58 degrees. So if the distance from the foot of the ladder to the building is 6 feet, so from here to here is 6 feet, find to the nearest foot how far up the building the ladder will reach. So I want to basically figure out this distance here. How far up the ladder or how far up the building does the ladder actually touch? So this is going to be my x. This is what I'm trying to find. I'm trying to find that length. So since this is a right triangle, we could see if we could do Pythagorean theorem, but I can't because I only have one number here and two unknowns. So I do have an angle, which tells me that I can use right triangle trig, which means SOHCAHTOA. So we have to decide what do we have here. So since I have 58, this side is going to be the opposite. This is going to be the adjacent. And the ladder would be the hypotenuse, but I don't have any variables on the ladder, and I don't have a number there. So I'm only going to use the x and the 6. So that tells me I'm going to be using the opposite and adjacent, which tells me I'm going to be using tan. So it's going to be tan of the angle, which is 58 degrees, equals opposite, which is x, over the adjacent, which is 6. Put this over 1 and cross multiply. So we get x equals 6 times tan of 58, just like the other lesson where we are just solving for x. And then we put that into our calculator, you get like 9.6. So it says to the nearest foot. So that would round up to about 10 feet. So the ladder, how far up the building will the ladder reach? The ladder reaches 10 feet, I should say about 10 feet up the building. So that's the answer to that one. So looking at this next example, now we have a diagram where we have another ladder that's 5 feet long. So this is the ladder again. It's leaning against a wall and it makes an angle of 65 degrees with the ground. Find to the nearest tenth this time the distance from the wall to the base of the ladder. So the distance from the wall to the base of the ladder. So this is going to be my x. So then we label what we have. So we're going to be using right triangle trig because we have one side and we're trying to find a missing side and we have an angle. So this side is the hypotenuse because it's across from the right angle. This side is the adjacent with respect to the 65-degree angle because it's next to it. So then when I think of this in terms of SOHCAHTOA, I'm going to be using the one with A and H. So I'm going to be using cosine, not opposite. So cosine of 65 equals adjacent, which is x, over 5. Put that over 1, cross multiply. So we get to the nearest tenth, we get x equals 2.1 feet. So to answer the question, the distance from the wall, so the distance from the wall to the base of the ladder is 2.1 feet. So notice I'm always making sure that I write some kind of sentence at the end that really is answering the question. All right, so let's try a couple more of these examples. So the next type of example is going to be about a shadow. So we have, it says a tree that casts a shadow that is 20 feet long. So let me start with my tree here. So here's my tree, and it casts a shadow that is 20 feet long. So the shadow is always going to be on the ground. So this is going to be 20 feet. And the angle of elevation from the end of the shadow, so down here, to the top of the tree, so the very top down to this, is going to be 66 degrees. Because remember, angle of elevation means from the horizontal line, or the horizon, up to the top of the tree, so going upward, because elevation is 66 degrees. And I know to start down here because it says from the end of the shadow. We want to determine the height of the tree. So that means I am going to figure out this height right here of the tree, which is going to be my x. So thinking about SOHCAHTOA, we have, this is our opposite. This is going to be our adjacent, and we're not going to use the hypotenuse. So that tells me that I'm going to be using tan. So tan of 66 equals opposite, which is x, over adjacent, which is 20. Put that over 1, cross multiply, x equals 20 times tan of 66. So x equals about 44.9. And it says round to the nearest foot. So to answer the question, this is about 45 feet. So we answer it, the height of the tree is about, or approximately, 45 feet. All right, so let's look at another example. So this example is talking about a communications company that's building a 30-foot antenna to carry cell phone transmissions. As shown in the diagram below, a 50-foot wire from the top of the antenna to the ground is used to stabilize the antenna. So find to the nearest degree, so the nearest whole number, the measure of the angle that the wire makes with the ground. So the measure of the angle that the wire is making with the ground. So these two segments, the angle between them. So that's going to be my x. So I'm going to look at this in terms of SOHCAHTOA again. So if I have x is going to be my angle, this is going to be the opposite side. This will be the adjacent, and this is going to be the hypotenuse. Notice I won't be using the adjacent because there's no number or variable there that I need. So I'm going to be using opposite and hypotenuse, which tells me I'm going to be using sine. So it's going to be sine of x equals opposite, which is 30 over 50. And now I need to solve this for x. So in order to solve for x, this is where we take the inverse. Because this time I'm trying to find the angle. So we have to undo the sine function. So we get x equals sine inverse of 30 over 50. So we put that into our calculator, making sure again that we're in degree mode because we're trying to get out a degree. And we end up with 36.9. So basically approximately 37 degrees. So the angle to the nearest degree is going to be 37 degrees. So the angle that the wire makes with the ground is about 37 degrees. So I'm not going to rewrite all of that, but to answer the question, it's 37 degrees. So let's look at 3 more different examples, more with looking at trees and trying to figure out the height. So that's another type of problem that's typical with these. So we've seen problems with ladders, we've seen problems with shadows. Another common problem is trying to find the height of trees or something, an object that's really tall. So we saw one example, but let's look at a couple other ones. So here's an example where it's not starting at the ground level. So we have Dan was walking through a forest when he came upon a sizable tree. So the tree was very tall and he wanted to estimate how high the tree is. So Dan estimated that he was about 40 meters away from the tree. So he's 40 meters. So really this is 40 meters down here, but it's also 40 meters up here. That distance between him and the tree is 40 meters. We know that so he was 40 meters away from a tree when he measured the angle of elevation. So here's my angle of elevation. So from the horizon up to the top of the tree was 35 degrees. And we're wanting to know how tall is the tree if Dan is about 2 meters tall. So if he's 2 meters tall, what that means is this section here is going to be 2 meters. So we want to know how tall is a tree, which means we need to actually find this entire thing. That's the tree's height. But before we can do that, we have to use the fact that we have this right triangle. And we look at this as we can find this length and then just add 2 to it, and that'll give us the height of the entire tree. So when I'm looking at the 35, this is going to be my adjacent, my next to side, and this is going to be the opposite. So thinking of this in terms of SOHCAHTOA, we're going to be using tan, opposite and adjacent. So it's going to be tan of 35 equals opposite, which is x, over adjacent, which is 40. Put this over 1 and cross multiply. So we end up with x equals 40 times tan of 35, which gives us about 28 meters. So then that tells me that if this is 28 meters, the entire height would have to be the sum of those. So you'd have to take 2 meters and add these up. So 28 plus 2 gives me 30 meters. So the height of the tree is 30 meters. Make sure that you remember to add on the 2 meters that's coming from his eye level, because basically we're measuring the elevation from his eye level. So let's look at another one of these where we're using the elevation from eye level. So this example here, it's the same situation. So here's the same picture that you just saw where he was looking at this tree here. But now what's happening is he turned around and saw a bigger tree that's the same distance away, so it's still that 40 meters away. But the difference is he thinks this one's probably at least 50 meters tall. So he's saying this whole tree is 50 meters. And remember, this is the same guy, so that tells me that this distance is going to be 2 meters, just like the other problem, because the guy's still going to be the same height. And when I'm looking at this side length, it's going to have to be 48 meters to add up to 50. So basically what the question then asks us is to use this right triangle with the 48 and the 40, and we want to figure out what the angle of elevation is. So after he figured, okay, it must be at least 50 meters tall, then he thought a moment, if it is 50 meters tall, I wonder what the angle of elevation is. I would measure from my eye level to the top of the tree. So from the horizon at his eye level to the top of the tree is going to be the angle of elevation. So that's where the X goes. So that's our goal. That's what he's trying to find. What angle will Dan find if the tree is 50 meters tall? So assuming this is 50, what angle does he find? So remember, this is a 48 here. So let's look at this. So if we're looking at this red triangle, using SOHCAHTOA, this is going to be my opposite, the angle. This is going to be the adjacent to the angle, this side here. So again, we're going to be using tan. So tan of x equals opposite, which is 48, over the adjacent, which is 40. You're going to take tan inverse of both sides because we need to cancel out these tans. And we need to get x by itself. So x equals tan inverse of 48 divided by 40, which ends up being like 50.19 something. So if it says, what will the angle be? The angle will be approximately 50 degrees. And I'm not going to worry about writing out the explanation, but we do know that the whole idea here, if this tree was 30 meters tall and the angle of elevation was 35, it seems reasonable to say that since this tree is approximately 50 meters, or we're assuming 50 meters, it makes sense that the angle of elevation is close to it. Also, we kept into consideration that he's 40 meters away, this being 50, him being 2 meters, left us with this 48 meter measurement. And then we just used our right triangles to figure it out. So let's just look at one last example with this, and this one's dealing with shadows, but it's also dealing with trying to find the angle of elevation. So we have this situation where we have a man who is 5 feet 9 inches tall is casting a shadow. So let's go ahead and draw this out. So I'm going to start with a stick figure here. Here's my guy that's 5 feet 9 inches. And he's casting a shadow that's 8 feet 6 inches long. And assuming that he's perpendicular to the ground, what is the angle of elevation from the end of his shadow to the top of his head? So from the top of his head, well, from the shadow to the top of his head is this angle here. So here's the triangle that we formed. Here's my angle of elevation. So from the horizon to the top of his head, this is what I'm trying to find. That's going to be my x. So in order to be able to do that, if you look, I have, this is going to be the opposite. This is going to be the adjacent. So I'm going to be using, if I look at SOHCAHTOA, I'll be using tan, opposite and adjacent. So tan of x is going to equal the opposite over the adjacent. But if you look at these, the opposite and the adjacent are in feet and inches. So 5 feet 9 inches. So let's convert it all over to inches so we're looking at the same measurements. So 5 feet is 5 times 12 because there's 12 inches in 1 foot. Gives me 60. 60 plus 9 gives me 69 inches. Where 8 feet is going to give me 96 inches because 8 times 12 gives me 96 plus the 6 inches. So with this one I end up with 102 inches. So now I can plug those in. The opposite's 69, the adjacent's 102, and now I'm going to take tan inverse of both sides because I need to get x by itself. So x equals tan inverse of this, which ends up being 34.077, something like that. We want to round to the nearest tenth of a degree. So that tells me that the angle of elevation is going to equal 34. This is going to bump up to a 1, so 0.1 degrees would be the angle of elevation for this particular situation.